skim over the sand dunes of Mars is, as yet, only a dream. But we have, in fact, sent robot emissaries to Mars. Their names are Viking 1 and Viking 2. The problem was where to land them. We knew that the volcanoes of Tharsis were too high. The thin Martian atmosphere would not there support our descent parachute. The Great Mariner Valley was too rough and unpredictable. The polar caps were too cold for the lander's nuclear power plant to keep it warm. There were fascinating places that were too high, or too windy, or too hard, or too soft, or too rough, or too cold. We worried about the safety of every landing site. Perhaps we were too cautious. Eventually, we selected two places. One, optimistically named Utopia, for Viking 2, and another, 8,000 kilometers away, not far from the confluence of four great channels, a landing site for Viking 1 called Chrysi, Greek for the land of gold. And so, after a voyage of 100 million kilometers, on July 20th, 1976, Viking 1 landed right on target in the Chrysi Plain. It was less than 80 years since Robert Goddard had his epiphanal vision in a cherry tree in Massachusetts. After hibernating for a year during its interplanetary passage, Viking reawakened on another world. The first thing it did was to call home, reporting a safe arrival. It began to rouse itself, according to instructions memorized months earlier. First, it put out a finger to test the Martian winds. Then, flexing its arm, it flung off a protective glove. Next, Viking prepared to sniff the air and taste the soil. Finally, it opened its eyes for a look at its new surroundings. Viking's first picture assignment was to photograph its own foot. In case Viking were to sink into Martian quicksand, we wanted to know about it before it disappeared. Back on Earth, we waited breathlessly for the first images. Viking painted its picture in vertical strokes, line by line, until with enormous relief we saw the footpad securely planted in the Martian soil. This was the first image ever returned from the surface of Mars. The cameras on each Viking lander revealed a kind of rocky desert. Beyond the lander itself, we saw for the first time the landscape of the red planet. It didn't look like an alien world. There were rocks and sand dunes and gently rolling hills as natural and familiar as any landscape on Earth. Forever after, Mars would be a place. We found that the Martian air was less than 1% as dense as ours and made mostly of carbon dioxide. There were smaller amounts of nitrogen, argon, water vapor, and oxygen. And there was almost no ozone, so the surface was not protected from the sun's ultraviolet light, as it is on Earth. On the warmest days, it was distinctly chilly, and every night the temperatures plunged to 100 below. In winter, the surface was dusted with a thin layer of frost. The landing sites were chosen because they were safe and flat. Even so, Viking revolutionized our knowledge of this rusty world. I would, of course, have been surprised to see a grizzled prospector emerge from behind a dune, leading his mule, yet the idea seemed strangely appropriate. But at least while we were watching, no prospector wandered by. We studied with exceptional care every picture the cameras radioed back, but there was no hint of the canals of Barsoom, no sultry princesses, no 10-foot-tall green fighting men, no thoats, no footprints, not even a cactus or a kangaroo rat. Perhaps there was life inside the rocks or under the ground. If so, it had left no traces. For most of its history, the Earth had microbes, but no living things big enough to see. Perhaps the same is true for Mars. The Viking lander is a superbly instrumented and designed machine. It extends human capabilities to other and alien landscapes. By some standards, it's about as smart as a grasshopper. By others, only as intelligent as a bacterium. There's nothing demeaning in these comparisons. It took nature hundreds of millions of years to evolve a bacterium and billions of years to make a grasshopper. With only a little experience in this sort of business, we're getting pretty good at it. In both landing sites, in Chryse and Utopia, we've begun to dig the sands of Mars. On a very small scale, such trenches are the first human engineering works on another world. The robot arm retrieves soil samples and deposits them into several sifters. Then, the soil is carried to 5 experiments, 2 on the chemistry of the soil and 3 to look for microbial life. The Viking biology experiments represent a pioneering first effort in the search for life on another world. The results are tantalizing, annoying, provocative, stimulating, and deeply ambiguous. By criteria established before launch, 2 of the 3 Viking microbiology experiments seem to have yielded positive results. First, when Martian soil samples are mixed together with an organic soup from Earth, something in the soil seems to have broken the food down, almost as if there were little Martian microbes which metabolized, enjoyed the soup from Earth. Second, when gases from Earth were mixed together with Martian soil, something seems to have chemically combined the gases with the soil, almost as if there were little Martian microbes capable of synthesizing organic matter from atmospheric gases. But the situation is complex. Mars is not the Earth. As the legacy of Percival Lowell reminds us, we are liable to be fooled. Perhaps the ultraviolet light from the sun strikes the Martian surface and makes some chemical which can oxidize foodstuffs. Perhaps there is some catalyst in the Martian soil which can combine atmospheric gases with the soil and make organic molecules.